change in potential energy is not defined. Change in potential energy is not defined for non-conservative force. It's not defined for non-conservative force. Therefore, U final minus U initial is minus of work done. So imagine this is one reference point. Here we have a body at height h1. Then same body is taken at height h2. So I can say final is mgh2. Initial U is mgh1. U final minus U initial will be mgh2 minus h1. That is work done by the gravity will be minus of mg h2 minus h1. Gravity force is conservative force is minus mg h2 minus h1. Or U final minus U initial is minus of conservative work done against conservative force. Work done against gravity, it was Wg. Shall I clear now this one? One more line.
Yes, sir.
After completing this chapter, हाँ, तो थोड़ा मैं एक और चैप्टर करके फिर पार्ट 2 स्टार्ट कर दूंगा. Delta U we got minus of work done by conservative force. So that means small change का integration is total change minus small work done on both sides. U initial minus U final, small change का addition is total change is minus of conservative force into displacement. So just copy this formula. Work done is nothing but force into displacement. The integration is total change in the potential energy. रब कर देता हूं इसको. Now few questions related to this. Suppose f equal to 2x and u at x equal to 1 is 10 joule. Then find u at x equals to 2. So we know U final minus U initial is minus of work done by conservative force. That means U2 minus U1 will be F dx from 1 to 2 minus, that will give minus of 2x dx from 1 to 2, that is x square upon 2 minus from 1 to 2, 2 cancel. Okay, please copy it.
Done, sir.
So it is minus of 2 square minus 1 square, which will be minus of 4 minus 1, that is minus of 3. So u2 minus u1 was 10. So u2 is minus 3 plus 10, u2 equals to 7. Follow the meaning now, how to do?
Yes, sir.
Next question is if f is in two component 3i plus 4j, u at 0 1 is 10 and u at 2 3 will be how much? This is the question. First you write down, then I'm explaining how to do. At least write final minus initial energy is minus of work done against conservative force. Okay, can I clear now?
Yes, sir.
Sir, 1 minute.
Yeah, sorry.
Yes, sir.
Now this force 3i plus 4j, energy is 0 1 2 3, means it is varying with respect to coordinate. So I can say f x is changing with respect to x. Iska integration we want from 0 to 1. 0 to x coordinate कितना इसका? 0 to 2. And second component fy changing with respect to y is from 1 to 3. ये हो गया पूरा work done against conservative force का negative. Now this is nothing but 3 dx because fx is 3 and fy is 4 dy from 1 to 3, 0 to 2.
Hmm.
Now I can say this is minus of integration of dx is x. So 3x 0 to 2 plus 4y 1 to 3. This much clear, meaning?
Yes, sir.
So minus of 3 into 2 minus 0 1 term plus 4 y is 3 then minus 1. So it will become minus of 3 into 2 plus 4 into 2. So we get minus of 3 2s are 6 plus 4 2s are 8. That is minus 14. Now u final minus u initial is 10 equal to minus 14. So u final equals to minus of 14 plus 10. Therefore u final is minus 4 joules. This is what not given in detail in our state board. This part. Copy now. So final energy, potential energy is minus 4. Yeah, done.
Yes, sir.
Yes, sir.
एक और अभी 3 वेरिएबल वाला करते हैं.
If conservative force is x square I cap plus yj cap plus z square k cap. U 0 1 1 is 10 joule. Then what will be U at 2 3 2? U final minus U initial is minus work done. So it will be minus of fx dx plus fy dy plus fz dz. X component is varying from 0 to 2, y is from 1 to 3, z is from 1 to 2. This, will you try this now on your own?
Yes.
Yeah, just try. Take 1 minute, 2 minutes.
-9.
Yeah, then what is the answer?
-9.
Plus 1 we are getting.
Yes, sir. Plus 1.
Plus 1.
Yeah, the 10 joule. Yeah, +1. Got it.
Correct, na? Plus 1.
Yes, sir.
So we got one idea. Potential energy is work done against the conservative forces. Gravitational potential energy. Generally, it won't come in work or energy. Again, we are going to study in chapter called gravitation. So if I consider this ground in our gravitational potential as 0 and this final as mgh, then gravitational potential energy is given by minus g m1 m2 by r. R is distance from the center, and if ground is reference, then mgh. Correct? Hey, hello.
Yes, sir.
If ground is taken as reference, then final is mgh. But gravitational potential energy is minus g m1 m2 upon r. Now, just tell me in this case, if this is one chain kept of length L, kept at height h from the ground, what will be potential energy? What will be potential energy here? All the masses are equidistant. All the masses, isn't it?
Yes, sir.
So it will be mgh. But if this is the mass kept vertical like this, and this is h, now where is center of mass? Here. In this case, potential energy, we don't take mgh. It will be mgh by 2. That means if mass is distributed throughout, not concentrated at one place, then center of mass will find, and then mg center of mass from the reference. Clear?
Yes.
Yes, sir.
लेकिन अगर ग्राउंड पे ही है वो, ग्राउंड पे अभी, what will be the potential energy here?
0.
0. Correct. लिखो ये तीनों. सर फर्स्ट वन तो लिखे ना, फिजिक्स स्टडीज क्वेरीज में देखो. हाँ मैं बता रहा. हाँ मैं समझ गया. तो ठीक है, बहुत अच्छा है. एक काम लोग जनरली को बच्चा कल मुझे क्या उन्होंने पूछा कि सर आप लोग पहले मुझे बताओ डाउट सॉल्व. तो कौन कैसा डाउट सॉल्व करेगा? एक पॉइंट रिगार्डिंग डाउट सॉल्विंग. पहला पॉइंट क्या आएगा? हाउ वी कंडक्ट द कोर्स. हाउ वी विल conduct the course. First point. नहीं, first point नहीं, वैसा नहीं. First point is how we are going to conduct the course. मतलब कौन सा टीचर क्या सिखाएगा, कौन सा चैप्टर. Second, doubt solving. Third, completion of the portion. Fourth, test. Fifth, mock test bracket में prelims. हाँ. नहीं, वो तो क्या, वो आपने बोला इसलिए मुझे भी क्लिक हुआ है. क्या कह रहे हैं? मतलब देखो, जनरली मैंने क्या सोचा कि पेरेंट क्या पूछेगा मुझे, तो सबसे मैं आपको बोल रहा हूँ यही तो. लिखे सर. हाँ. सबसे पहले कंडक्शन ऑफ द कोर्स, देन डाउट सॉल्विंग, उसके ऊपर हम लोग बात करेंगे. हाँ. थर्ड, completion of course. Fourth, test. Fifth, mock test bracket में prelims. हाँ ठीक है. वो मतलब मैंने वही इसलिए वैसा किया, चैप्टर वाइज टेस्ट होगा क्या नहीं, तो इसलिए खाली टेस्ट बोला, तो उनको हम एक्सप्लेन कर देंगे चैप्टर वाइज और कॉम्बो टेस्ट. और लास्ट वाला मॉक टेस्ट नहीं, मॉक टेस्ट में हम कॉम्बो टेस्ट बोल देंगे ना सर. मॉक टेस्ट में हाँ मॉक टेस्ट में हम लोग प्रीलिम लेंगे, मिनिमम 40, तो 40 पेपर हमको उसके विद सॉल्यूशन तैयार करना है बस, है ना। हाँ मतलब नहीं वो हम लोग को एक्सप्लेन करना है ना सर। तो देखो मैंने आपको भेजा है कि कौन कौन क्या चैप्टर ले रहा है। नहीं उसमें कुछ नहीं है, उसमें कुछ नहीं। मैं आपको फिर एक फोन करता हूँ सर, फिर एक फोन करता हूँ 1:30 बजे के, 1:45 बजे। हाँ चले। आपका कितने बजे खत्म होगा लेक्चर? 3:30। हाँ मेरा भी 3:30 खत्म होगा, उसके बाद में 5 बजे तक चलेगा। चलेगा चलेगा, यस 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 जरूर, हाँ डाल दो ना, चलेगा चलेगा, यस। Yes, beta. Then all the points clear now. How to get potential energy?
Yes, sir.
Yes, sir.
If all the masses are same distance, then mgh. If it is distributed, then center of mass. If it is on the ground, then 0. Next one. This is one circular frame, and chain is only this much. Now we are interested in what is potential energy of the chain. What is potential energy of chain? थोड़ा सा ये आने का चांस कम है, बट एज यू आर रिपीटिंग कंसेप्ट थोड़ा समझ लो कैसे निकाल सकते हैं इसका। लुकिंग एट द स्टैंडर्ड ऑफ द पेपर नाउ, आई डोंट फील दे विल आस्क दिस। See, this mass is again not, all the masses are not at fixed place ना, सब अलग अलग डिस्ट्रीब्यूटेड है ना सेंटर से। if this is r, this is r, हर एक का पोजीशन अलग है। तो हम लोग क्या करते हैं, एक छोटा सा इधर एक टुकड़ा कंसीडर करते हैं ऑफ मास dm। total mass is m, let dm be the elemental mass making angle d theta, and theta be the angle made with the horizontal. This same concept we will also get in chapter called electrostatics to find the intensity if charges are distributed on the ring. If this elemental mass is at height h, can you tell what will be h in terms of r? R sin theta. This is r, this is theta, तो ये height क्या हो जाएगा? R sin theta.
Yes, sir.
R sin theta. Now our small energy du will be dm into g and height h of that particular elemental mass. So I can say it is dm into g r sin theta. So total potential energy will be total of all small masses ka potential energy added. Now wherever you see r, we know that arc, length of arc is radius into angle. So this length of arc is r d theta. Okay, just copy it in this. Just copy this one.
सर एक और बार एक्सप्लेन करो ना।
देखो एकदम सिंपल, ये चेन ऐसा डिस्ट्रीब्यूटेड है इधर से इधर, बराबर।
हाँ।
अभी इसका मास, हर एक पॉइंट मास अलग अलग डिस्टेंस पे है फ्रॉम द सरफेस। ये इधर है, ये हाइट अलग है, ये हाइट अलग है, ये हाइट अलग है, अलग अलग है ना।
यस सर।
तो आई कैन टेक mgh। इफ आई कैन टेक mgh तो मुझे कुछ इंटीग्रेशन मेथड यूज करना पड़ेगा। तो इधर छोटा सा एक टुकड़ा एज्यूम किया ऑफ मास dm जिसका हाइट h है फ्रॉम द सरफेस।
हाँ।
तो मुझे उसका एनर्जी मिल गया dm into g into h by mgh मेथड।
यस।
अभी h मतलब r sin theta because r is constant, तो कांस्टेंट में लाया।
हाँ समझा।
तो अब ये पूरे का इंटीग्रेट करना है। अब ये थीटा में आंसर को लाना पड़ेगा ना, तभी तो इंटीग्रेट करूंगा ना।
हाँ।
तो इसलिए अभी नेक्स्ट टाइप ये डीएम का मास आई एम गोइंग टू फाइंड इन टर्म्स ऑफ थीटा.
Okay.
ओनली द डायग्राम वाला साइड क्या नहीं क्लियर?
Yes, sir.
Yes, sir.
अभी देखो वो आर्क आर डी थीटा में जो भी मास है ना उसका मास मुझे पता लगाना है, वो डीएम. व्हाट इज टोटल लेंथ ऑफ द आर्क विच इज गिवन? टोटल लेंथ वेयर मास m is distributed.
In this length, this arc, this is nothing but pi r upon
Pi r by 2.
pi r by 2 बराबर, बिकॉज टोटल होएगा 2 pi r, ये 1/4 है, तो 2 pi r upon 1/4 किया तो pi r by 2 आ गया. That means pi r. Can I remove everything from the screen here?
Yes, sir.
sir.
Yes, चलो अभी देख लें. Since pi r upon 2 corresponds to mass m of the chain. This line I think clear. So our arc RD theta has mass dm. So I can say dm will be m cross multiplying by unitary method. mr d theta upon pi r by 2. This rr will get cancelled. So it will become 2m upon pi into d theta. So mass dm is obtained as 2m upon pi d theta. Are you clear?
Yes, sir.
Please copy till this. So dm is 2m by pi d theta into gr sin theta का integration will give me total potential energy. Can you tell me what is angle changing from? ये वाले arc में किधर से किधर तक? 0 to pi by 2 or not? Limit of integration 0 to pi by
Yes,
2.
sir.
So 0 to pi by 2 is my limit of integration. Now 2 is constant, m is constant, g is constant, r is constant, pi is constant. So inside we get sin theta d theta from 0 to pi by 2. That is 2 constant, m constant, g constant, r constant, pi. This is minus cos theta from 0 to pi by 2. So 2m gr by pi minus cos 9t minus minus plus cos 0. Cos 0 is 1. So 2m gr upon pi, this thing will become 1. This is the answer for potential energy of that chain which is distributed on 1/4 of the quadrant or in a quadrant. So this we got general, only that 0, this limit of integration will change for different angles, 0 to 180.
Yeah, done.
Yes, sir.
Yes, sir.
For spring. Imagine this is spring tied to block of mass m, block of mass m. If we stretch it by distance x1, then restoring force will be minus k x at any distance. The work done will be minus f dx from x1 to x2. Then we will be using that concept that change in energy is equals to minus of conservative force. ये बाद में करता हूँ, अभी खाली ये force से work done निकाल देता हूँ. So this will be equals to minus kx dx from length x1 to any other position x2 will become minus k x squared by 2 from x1 to x2, which is minus k by 2 x2 square minus x1 square, that is minus k by 2 x2 square plus k by 2 x1 square. Since change in potential is minus of the conservative force ka work done. So U2 minus U1 will become, changing the sign throughout, half k x2 square minus half k x1 square. But when string is unstretched, that is x1 equal to 0, then potential energy will be 0. So I can say U2 minus 0 equals to half k x2 square, because second term is 0. So half k x2 square, or in general from start half k x square is the potential energy stored in the spring. अब खाली लास्ट लाइन लिखना, कॉन्सेप्ट समझ गया ना, मीनिंग क्या था? और पूरा लिख लो, चलो लिख लो. हाँ सर, हाँ सर, मान लो. नहीं ठीक है, कोई बात नहीं. हाँ. ठीक है, कोई बात नहीं. नहीं यार, ठीक है, तो कोई बात नहीं, क्या करें, ठीक है.
Yes, done.
Yes.
Yes, sir.
See, if
Yeah.
it is
Yes, sir.
starting from 0 position, then half k x square is the direct answer. But if it is starting from x1 x2, then remember difference will be the answer. Half k x2 square minus half k x1 square. एक मैं आपको सम डिफरेंस वाला कराता हूं. This is a block connected to the spring having Ks 100 Newton per meter. Then it is stretched up to 1 meter and then up to 2 meter from the mean position. Find work done by spring force, in stretching from x equals to 1 to x equals to 2. So same concept, u final minus u initial is minus of work done by spring force. So half k x2 square minus half k x1 square minus of work done by spring force. So half of k into x2 is 2 square minus half of k x1 is 1 square is equals to minus of work done by spring force. So this will become half k 2 square minus 4 minus 1 3 equals to minus of work done by spring force. Half of 100 into 3 is minus of work done by spring force. That will be now 50. So minus 150 will be work done by spring force. Clear? Meaning now how to get work done? If they give this type of stretching from two position,
Yes, sir.
solve. देखो ये सब difficult part I am doing in the class. Then MCQ में फिर से solve करो. That's why this is not like MCQ based. It is theory based.
Done, sir.
One very interesting sum now. A spring has force constant K tied to the block of mass M. Due to this block, it gets stretched by distance x. And comes under equilibrium. The block will create force F. So I can say that means spring force Kx is created by mg. So extension will be mg upon k. Now what is potential energy U of mass due to spring? Potential energy is half k x square for the spring, but x in terms of mass is mg upon k. So this will become half k m square g square upon k square. So therefore it is m square g square upon 2 is potential energy if it is block spring system in terms of mass. Okay. Hello.
Yes, sir.
Yes, sir.
Potential energy of the mass due to spring will be this because it is doing work against that spring force. So please write down, draw the diagram and write to.
Done, sir.
If I consider this as reference, this is block and spring system having force constant K. It elongates by distance x and comes to rest here at height h from the surface. We want what is total potential energy. So, एक तो potential energy इसका height की वजह से होगा mgh आएगा, दूसरा आएगा plus half k x square due to this elongation, that is mg upon k, just now I did. So in this case it will be mgh plus half k m square g square upon k square, 1k cancel. So mgh plus half m square g square upon k is total potential energy if we consider reference say at height h that body comes. So this is also one of the case of spring block system. Right, now diagram and then this. Okay.
Yeah, can I grab this?
Yes, sir.
Yes, sir.
Now, what is meaning of equilibrium in case of body? Precisely, we are talking about mechanical equilibrium because there can be thermal equilibrium also. When net force acting on a system, when net force acting on a system is zero, that is when summation of force is zero, then system is said to be in equilibrium. Total force acting on system is zero, then it is said to be under equilibrium. There are three types of equilibrium. Three types of equilibrium. First is called stable, second is called unstable, and third is called as neutral. So just write this, then I'm explaining what is stable, what is unstable, what is neutral. Yes, done?
Yes, sir.
Yes, sir.
Okay. हम लोग बोल रहे हैं कोई भी इक्विलिब्रियम होगा तो नेट फोर्स एक्टिंग जीरो, फिर चेक करना स्टेबल कभी होगा, अनस्टेबल कभी होगा, न्यूट्रल कभी होगा. Now just now we said potential energy is nothing but work done which is equals to minus of force into displacement. That means increase in potential energy is work done, नेगेटिव को इधर ले लिया तो माइनस आ गया. That means we can say du upon dx in minus equals to f. For equilibrium, f is 0. That means du by dx is 0. Clear now? This much?
Yes, sir.
Have you heard about this? Something upon x. ये तो एक्चुअली स्लोप है ना, स्लोप
Gradient.
ऑफ u, हाँ ग्रेडियंट बोलते हैं. स्लोप ऑफ एनर्जी वर्सेस x का ग्राफ है का ये स्लोप है. बट I can say du by dx is slope of u versus x. ये स्लोप जीरो कभी होगा, मैक्सिमम पे होगा, इधर मिनिमम पे होगा, मैक्सिमम पे भी होगा, और जब भी कांस्टेंट है तभी भी होगा ना. तीन जगह पे हो सकता है ना जीरो.
Yes, sir.
देखो इधर मैंने लाइन बनाया पैरेलल टू x एक्सिस जीरो, इधर बनाया जीरो, ये कांस्टेंट है तो भी जीरो. तो स्लोप इज जीरो एट थ्री प्लेसेस. स्लोप इज जीरो either at minimum or at maximum or at constant. So based on this there are three equilibrium. If potential energy is minimum, then stable equilibrium. Potential energy is maximum. I know from maths you know for maxima or minima slope is zero. तो मिनिमा मैक्सिमा दोनों के लिए स्लोप जीरो हो गया. तो ये स्टेबल इक्विलिब्रियम है जिधर पोटेंशियल एनर्जी मिनिमम है. ये अनस्टेबल मैक्सिमम है, ये कांस्टेंट जिसको न्यूट्रल बोलते हैं.
फॉर एग्जाम्पल एक बॉल को मैंने इधर शिफ्ट कर दिया, ये स्टेबल है ना, इसके आगे पीछे नहीं, रेस्ट पे आ गया. If I push it slightly upward, what will happen? Again it will come back, है ना?
Yes, sir.
Whether I put this side, again it will come back, मतलब स्टेबल. इधर ये लोएस्ट पोजीशन पे है ये पूरे बॉडी का, तो मिनिमम है पोटेंशियल एनर्जी. लेकिन ऐसा रख दिया, अगर इसको पुश किया तो ये रिटर्न नहीं आएगा, इसका मतलब ये अनस्टेबल है. लेकिन पोटेंशियल एनर्जी मैक्सिमम है क्योंकि हाईएस्ट पॉइंट पे. इधर बॉडी को अगर मैं चेंज करूं तो इसका पोजीशन फिर से रिटर्न नहीं आएगा पुश किया तो, लेकिन पोजीशन नहीं चेंज हो रहा है, मतलब पोटेंशियल एनर्जी यहाँ पे उसका कांस्टेंट है, मैक्सिमम मिनिमम कुछ नहीं. तो मिनिमम तो स्टेबल, मैक्सिमम तो अनस्टेबल, नॉट चेंजिंग, दैट इज कॉल्ड न्यूट्रल इक्विलिब्रियम. ऑल द थ्री केसेस क्लियर?
Yes.
Yes, sir.
मतलब एक्चुअली क्या है, स्टेबल पुश करके छोड़ दिया तो वापस अपना जगह पे आएगा, वो स्टेबल है. पुश कर दिया तो पीछे नहीं आएगा लेकिन उसका एनर्जी कम होते जाएगा, वो अनस्टेबल. पुश कर दिया पीछे नहीं आ रहा है लेकिन एनर्जी चेंज नहीं हो रहा है, तो उसको हम लोग बोलते हैं न्यूट्रल. ओके, इधर से समझ में आया आपको बराबर कंसेप्ट? चेंज इन पोटेंशियल एनर्जी इज माइनस एफ डी एक्स, उसका ही मतलब डी बाई डी एक्स हो गया. बट अगर मुझे फोर्स जीरो लेने का इक्विलिब्रियम के लिए तो डी बाई डी एक्स जीरो चाहिए. लेकिन डी बाई डी एक्स क्या होता है? स्लोप ऑफ यू अगेंस्ट एक्स का ग्राफ. तो इधर मैंने ग्राफ बनाया, इधर भी जीरो, इधर भी जीरो, इधर भी जीरो, तीन जगह पे जीरो आ सकता है. तो इसको बोलते हैं स्टेबल, ये अनस्टेबल, न्यूट्रल. एग्जांपल मैंने इधर भी समझा दिया, स्टेबल, अनस्टेबल, न्यूट्रल. ओके,
Yes, sir.
but for
Yes, sir.
all equilibrium du by dx should be zero. Now write with proper diagram, first this part, then this, and then this. If you have completed, then tell me so that I can clear and explain from equation whether you can say it is stable or unstable or it is neutral.
Yes, sir. Done.
पूरा हो गया?
Done, sir.
ये तीनों डायग्राम भी हो गया?
हाँ सर.
हाँ.
सबका हुआ? जेनिफर?
Yes, sir.
यश हो गया डायग्राम?
Yes, sir.
Okay. The question goes like this. U is x square minus 8x. Find position of equilibrium. मतलब where it will come under equilibrium, and state type of equilibrium. If slope is minimum, then it is stable, maximum unstable, no change, then it is called as neutral. So where it will be equilibrium, wherever it is equilibrium, their rate of du upon dx should be 0. So u is x square minus 8x, du by dx will be 2x minus 8. For equilibrium, du by dx should be 0. That means 2x minus 8 is 0. 2x is 8. X equals to 4. So it will be at equilibrium when x is 4. Which type of equilibrium? That depends करता है ये minimum है क्या maximum है क्या no change वाला है. Please copy it in this. if I take second order derivative, मतलब फिर से एक बार derivative and get the answer as greater than 0, then it is called as minimum energy, or then this is this वाला slope 0, और अगर negative मिला तो ये वाला है, और 0 आ गया तो ये वाला है. So first for equilibrium, take derivative of potential energy as 0. So we got at x equal to 4, it is equilibrium. Now we have to check whether that potential energy was minimum, maximum, or 0 at that point. So at x equal to 4, either maxima or minima, derivative is 0. Shall I rub this everything?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Now since du by dx we got as 2x minus 8, once again when you differentiate it will become 2. 2 is greater than 0. Therefore u is minimum. Therefore equilibrium is stable. Sorry. Yes, done my phone.
Yes, sir.
Now with this concept you can solve many sums of the PDF which I